Yo, what's up guys? So today we'll be talking about the transformations of functions. So first of all, if you like this content and want to see more, consider subscribing, but let's get into the video. This is a very visual chapter, so I suggest you check these out and experiment on your own. So what the first thing I'm going to cover is when you think of a quadratic function, what do you think of? Well, you think of, let me go back. What you think of is y is equal to x squared, okay? Or something like that, some combination of that. So maybe, maybe more of the form y is equal to x squared plus bx plus c. But I want to propose another way to think about it, especially when you're doing transformations. Think about it like y is equal to a times x minus h squared. Sorry, that's an h squared plus k, okay? And each variable here, besides x, has a very important role in how the function is going to work. So k is going to be the y level of the highest or lowest point. So if I were to have, I don't know, normally it's with just plus 0, right? And let's just use this as an example. Y is equal to x squared, the base function, okay? So it goes through the middle. So it goes through the middle and up here. It's kind of bad, but whatever. Here, okay? But if we were to say, okay, well, if we had x squared and we were to add, I don't know, 3, what would actually happen is the resulting parabola would be moved 3 up. And same thing if we did plus negative 3 or minus 3, it would be moved down 3 units. And of course, if you want to have if it was a negative parabola, so y is equal to the negative of x squared, it would look like this, right? And if you were to add 3 to it, it would look something like this, right? Something like that. Sorry, I'm not good at drawing graphs. Now with the next one, h. So the h is how far left or right you move your function. So, and you're like, okay, well, why is it minus h, not plus h? Well, when you have minus h, you move right, and when you have plus h, you move left, okay? So it's just easier to write it as x minus h, because if you were to move it negative, if you were to move it, I don't know, 3, here, let's get our base example again. So if we were to move it 3 to the left, or negative 3, we would write it as, sorry, that's bad, as x plus 3 squared, right? And it's easier to think about it as x minus negative 3, so that you know that you're moving it at negative 3 units. Now for our next one is a. A is basically just how squished, a better word is compressed or stretched your function is. So for a, let's get our base function, y is equal to x squared, and here just plus, there we go. And if we were to have if our a was greater than 1, it would be more compressed, so it would be kind of, or stretched is kind of maybe a better word, kind of stretched vertically. And if it were below 1, it would be compressed vertically. So here, let me redraw that. That was bad. It might be compressed vertically, so it might look something like that, some more flat. Later in the video, I'll start to get more in depth with this stuff. So let's move on. Now we're going to be talking about reflecting functions. So what does this mean? Well, if we were to have, let me get our axes out, y and x and y axes. Let's something like this, x, y. So if we had a function, maybe like this, something like that, and we wanted to flip it across the y-axis, how do we do this? Well, this, here, let me fix this. F of x, okay? Let's just write it as f of x, okay? So, how can we flip this across the y-axis? Well, what you do is this new function that we're going to create, let's call it g of x, is going to be f of negative x. So wherever the x is, we're going to substitute it for negative x, okay? And that's going to result as a flipped function, something like that, okay? But how do we flip this across the x-axis? Well, if we wanted to flip it across the x-axis, let's have we have h of x. We are going to write it as -1 or just negative f of x. So if we flip that, something like that, okay? And notice it looks similar, and I'll get to that in a second, okay? And notice this looks very similar to flipping across the y-axis, and I'll explain what this means later. Now I'm going to tell you why these kind of work and how they flip them, basically. So I like to use the example of a square root function. So let's say f of x, or actually we can just write it over here. F of x is equal to the square root of x. And that gives us a graph that kind of looks like that, okay? Something like that. So how can, and obviously you can't have a negative square root, so it can't go to negative x's, and we're just going to be working with the principal square root, okay? So just get that out of the way. So how can we flip this across the y-axis? Well, what I told you here is that if we make x negative, and so then you get something like this, and notice it was reversed across the y-axis, and that's because all the negative values are positive and all the positive values are now negative, okay? Well, how can we then flip this across the x-axis if we wanted to? Or let's go back to our base. How about that? Let's go back to our base function. Let's flip it across the x-axis, okay? Well, how we can do that is make negative f of x instead of f of negative x. And why this works is, what we know is that instead of making the x itself negative, we make the answer negative. And because the answer is the y value, it flips all the answers to be negative, right? Because if we had, for our g of x, if we plugged in -16 is equal to f of x of +16. So it's going to be the square root of 16, which is equal to 4, right? But for h of x, if we had h of 16, then instead of that being flipping that, so making it -16, we make the output negative. So if we had -16, that results to 4 times -1 is -4. So we just flipped it across the x-axis. And of course, if you wanted to flip it across the y and x-axis, this new function, how about L of x is going to be equal to negative f of negative x. So that flips it across the y-axis and then the x-axis. So we get something like that.